11.3, define and use probability. Objective, find the likelihood that an event will occur. Let's take a look at probability. Probability, the lowest is 0 up to 1. 0 meaning event will not occur, and 1 meaning the event is certain to occur. And all in between are our probabilities. Let's take a look at theoretical probability. A theoretical probability is the number of outcomes in an event A out of the total number of outcomes. Let's take a look at an example. If you roll a standard 6-sided die, find the probability of rolling a 5. So the probability of rolling a 5, the favorable is 1, and the total number is 6. So we say the probability is 1/6. What is the probability of rolling an even number? Well, an even number could be 2, 4, and 6. So the favorable is 3, the total is 6, and so the probability of rolling an even number is 1/2. Let's take a look at experimental probability. This is where we use an experiment. We take the number of trials where the event occurs divided by the total number of trials. For instance, here is an experimental probability. We want to find the probability of at least 40 years old. At least 40 years old is starting at 40 or up. And we can see that the favorable will be all of these numbers added together, which is 1,089, out of the total, and total means adding them all up over here. And we can make this into a decimal, and the probability will be 0.310, which is on the least likely side. Your turn. Stop the screencast and see if you can find the experimental probability. And here is the answer. Let's take a look at using permutations or combinations in a probability. The first one says, what is the probability that the musicians perform in alphabetical order by their last names? Now remember, there are 7 musicians. So order is important. So we are going to put in the denominator the total number of orders we can have. Only one of those orders is going to be in alphabetical order. So this is the probability, 1 over 5,040. Number 2, you are friends with 4 of the musicians. What is the probability that the first 2 performers are your friends? The first thing is we got to look at is that order is not important. We're only choosing 2 out of the 7 musicians. So this is going to be our total number. But the favorable will be out of the 4 people who are your friends. So choosing 2 out of the 4, this is the favorable outcomes. So that'll be 6 over 21, which reduces to 2/7. Pause and see if you can find this one. And this is the answer. Very similar to the last problem. We want to find the probability of 2 months with 31 days. So out of the 12 months in the year, this is going to be the total number of outcomes of choosing 2 months out of the 12. The favorable will be the 31 days. In 31 days, there's only 7 that are favorable, and we're only going to choose 2 of them. And so this will be the answer. Okay, let's take a look at the probability, compound probability, where we look at independent events and dependent events. So we're going to look at the probability of A and B occurring. And A and B are going to be independent events. And then we're going to take a look at A and B, where A and B are dependent events. Let's look at the first example. Here is a spinner, and we would like to find the probability of spinning a 5 and then spinning something that's greater than 3. Okay, these are what we call independent events. So spinning the first time and spinning the second time don't depend on each other. Now, getting a 5, the probability of a 5 right here is there's only 1 out of 4 chances here. And then a number greater than 3. Number greater than 3 would be 4, 5, 6, 7, and 8. And that happens to be 5 favorable out of the 8 possible. So we're going to take a look at this formula, and we're going to use that. And then this answer is going to be 5 out of 64. And this is the probability of getting of 5 and greater than 3. Let's take a look at this. Now this is an example of dependent events. When it's dependent events, it's going to be the probability of A times the probability of the second event dependent on A. A bag contains 20 $1 bills and 5 $100 bills, and you randomly draw a bill from the bag set aside, and then randomly draw another bill from the bag. Find the probability that the first bill is 100 and the second bill is 100. So there are 5 $100 bills, 5 out of the 25. So to get the first 100, here's the probability. Now, because the second 100 is dependent on the first drawing, remember once 100 is drawn, you no longer have 5 $100 bills. You now have 4. So you have 4, and you no longer have 25 bills in the bag. You now have 24. So this second probability is depending on the first probability, and that if you do all your simplification and multiplication, you'll get 1 over 30. All right, let's take a look at comparing independent and dependent events. Suppose you randomly select 3 cards from a standard deck of 52 cards. What is the probability that all 3 cards are hearts? You replace each card before selecting the next card. So the A part is what we call independent. So choosing each heart does not depend on the previous choice. So there's 13 hearts out of 52, 13 out of 52, 13 out of 52. We use the independent formula, and if you simplify, it's 1 over 64. Now what happens if you do not replace? If you do not replace 13 out of 52, and then there's less hearts, there's 12, and there's less cards, 51, less hearts, 11, less cards, 50, and then you will get this answer. Let's take a look at compound events where we use the word or. And we have a formula when this is overlapping, when your event A and B are overlapping, and when your A and B are disjoint. They're not overlapping, they're separate from each other. So let's take a look at disjoint. So we'd like to find the probability of getting a 10 or a face card. Now this is a disjoint. 10s and faces don't share anything in common. So there are 4 10s out of 52, and there's going to be 12 face cards out of 52. And when you add these together and simplify, it'll be 4 over 13. Now let's take a look at what happens if there's overlapping. So suppose you want the probability of a face or a spade. Now face cards and space cards overlap right here. This is where they have in common. So what we want to do is, we're going to find the probability of both of them, add them together, and then subtract the overlapping. So there are 12 face cards out of 52 plus, and spades, there are 13 out of 52. And we're going to have to eliminate the overlapping, and there's happened to be 3 that are both spades and face cards out of 52. And then if you go ahead and do all this, you're going to get as soon as you add them all and then reduce, you're going to get 11 out of 26. Okay, your turn. Pause. And here's the answer. This is an or. Pause. Another or. And this is also independent, so you just add these together.